This is the model of microstructure of compact bone. This is periosteum, and these are the different Haversian systems in the compact bone. We will also see different lamellae. We will see one by one. Structural unit of compact bone is Haversian system or osteon. So all these are osteons, different osteons arranged side by side longitudinally along the length of the bone. This is the transverse section, this is the longitudinal section, and every osteon will have central canal. The central canal allows the capillaries to pass through it, the fine nerves and lymphatics to pass through. Surrounding every central canal, the bone is arranged in the form of thin plate. These are called lamellae. There are 6 to 10 lamellae around central canal in each Haversian system. The numbers may vary. See, these are all the concentric lamellae around the central canal. In between the lamellae, if you go observe, there are spaces for the osteocytes to be located. So these spaces are called lacunae. Every osteocyte which are in between the lamellae are communicating with each other with fine canals which are passing through the lamellae. So these are called canaliculi. These canaliculi help in diffusion of nutritive materials from the central canal towards the osteocytes which are located in the peripheral most part of the osteon or Haversian system. These are concentric lamellae. For understanding, they have been pulled up. Let us look at different lamellae. In concentric lamellae 1, 2, 3, if you take cross section of the same, so these are represented by cross sections here 1, 2, 3. So these lines tell us that these are the this is how the collagen fibers are arranged in different lamellae. In the lamellae inside and outside and outermost side, the collagen fibers are perpendicular to each other. So this is running in this direction, these are running in this direction, and again these are running in this direction. This is how they increase the tensile force or the strength of the osteon. There are two more different types of lamellae. They are circumferential lamellae and interstitial lamellae. So inside to the periosteum, so this is periosteum. So we can see the bone is in the small plate. So this is one plate and this is other plate. So this is circumferentially arranged in the compact bone just below the periosteum. So these are outer circumferential lamellae. In the same way, if it's not shown here, if there is endosteum, so just outside to endosteum towards the bone, we find circumferential lamellae like this only. They will be called inner circumferential lamellae, which is not shown in this model. So there are two types of circumferential lamellae, outer and inner, inside to the endosteum and outside to the, inside to the periosteum and outside to the endosteum. After circumferential lamellae, so there are several lamellae which are in between the osteons. So these are the lamellae, concentric lamellae, in between the osteons. So these are interstitial lamellae. This is the osteocyte in the interstitial lamellae. So these are interstitial lamellae. These are representing the old osteon which has been replaced by the new osteon. We know that bone is continuously changing structure. It's dynamic. The new osteons are getting formed according to the need and demand by the nature. So that's how it is getting destructed and reformed. So these are the new osteons formed, and interstitial lamellae are here. In longitudinal section, we see Haversian canal cut longitudinally, and the canal which connect two different Haversian canals are called Workman's canal. These not only connect two Haversian canals, they can also come inside and connect the bone marrow, or they can go outside and connect the periosteal vessels also. These are called Workman's canal. This is the arrangement of osteocytes in longitudinally cut osteon. Where will we see cement line? Cement line is the outermost limit for any osteon.